Next, we're cutting everything that's in the 3-axis mode as the machine is in the neutral position. Okay, the next operation, we're going to profile the entire part to clear out a lot of the stock that's around it. So we're going to go and I think we just use a standard 2D contour. We could use an adaptive clearing, but I'm going to do 2D contour instead. Okay, we'll keep our default settings here. Go to geometry. Going to hide the stock. And then we're going to select the edge that makes up the entire bottom profile. Going to make sure the arrow is offset to the correct side. We're going to go to heights. We're going to go ahead and leave this at stock top just until the outside's cleared. I think it's a little safer when you get into the 5-axis. So we'll just leave that at stock. It's only a 200 thousandths difference and when it changes to rapid. We're going to go to the selected contour and I'm going to suggest that we go -0.005 deeper. Now make sure you got 2 zeros there. We're going to go about 5 thousandths deeper just to make sure we don't get flash left behind in our when we flip this part over. Okay. We're going to go to the the passes tab. We're going to go wear compensation. We are going to do roughing passes. Let's put the maximum step over at 1/4 inch. Sorry, 200. I keep typing something different than what I said. 250 thousandths. We're going to do multiple depths. Our maximum roughing step down is going to be also 1/4 inch. Our finishing step down will be 10 thousandths. Now we're going to do 1 at the bottom. It's going to act more like a spring pass for any deflection that's in the cutter. Safe, I believe, the finish only at final depth. With this cutter, we are going to rough the final. We're going to use even step downs. And we're not going to select these islands. No stock to leave. We don't need the smoothing on. There's no radiuses on there. Going to our last tab, we have the linking tab. And we are going to do the 90-degree sweep angle. We are going to do linear lead in. We can leave those at default because we're doing a radius. And but I do want to get rid of this vertical lead in radius. And I want to select our starting position as this edge here, this corner here. That way we can see it. And it's on the corner, so hopefully we don't get any gouging there. Is it okay? Alright, looks pretty good. Okay, next we're going to clear out the top here. We're going to do a 2D adaptive clearing. We'll leave everything at default. So we're going to go to geometry and we're going to select just the edge of this island, which should give us the entire face here. Okay, and then we're going to go on to heights tab. We'll leave all this at default. Go to passes. We're going to do multiple depths. The maximum step down is going to be 1/4 inch. And I'm going to leave a little less material in this. We're going to do 10 thousandths for axial and radial. Go to the linking tab. Except for the vertical lead-in radius, I think we're going to leave most of this at default. We're going to change from helix to plunge. And we'll leave the ramp clearance at 100 thousandths. Is that okay? Okay, so we've cleared out most of the material. Now we need to go in and do our finish cuts. Okay, so we're going to do a 2D contour. We're going to contour the edge here. So follow that profile. But we're going to put in steps to rough all the way across this because we need to clean up the face here. There's a couple ways you can approach this, but so we're still using our 1/2 inch end mill. We'll leave all that at default. Then we're going to go to our heights tab. We'll leave this all at default. Then we're going to go to passes. We're going to use wear control. We are going to do roughing passes. Our maximum step over is going to be 80% of the cutter diameter. So that worked out to be 400 thousandths. But we're going to do 5 roughing passes and see if that covers everything. No stock to leave. Our roughing step over, or finish stepping over, we're going to change that to 0.01, which is what we left as material to be left behind. And then we'll go to our linking tab and we'll leave everything at default except for our vertical lead in and hit OK. Alright, looks like we got one extra pass. We don't need that additional pass that's out here just cutting air, because you can tell it's not cutting air because the next one is next to the part and this one's a little bit farther out. So let's just go back. We're going to go to edit, go to our roughing passes, and we just reduce that to 4 step overs. Okay, so we should have the rough shape, all of the outside features there. And now we just need to do this hole here. Now this hole is a little bit over a 1/2 inch. It's allowed for a slide fit. So let's go ahead and do a 2D contour. We're not going to put a special drill in for that, and we don't have room for the drill point. So we'll do our 2D contour. We're going to switch to a smaller tool cutter from our UMC library. Let's go down to our 1/4 inch end mill. And we'll take the default feeds and speeds. We're going to go to geometry. We're going to select the bottom of the hole. Make sure the arrow is on the inside. The heights tab, we'll leave everything at default. Under passes, we might want to slow our finish feed rate down. Slow down a little bit to 20. We're going to do roughing passes. Maximum step over, we're going to put 1/8 of an inch because this is a fairly small hole in proportion to the end mill we're using. 1 step over, multiple depths. We're also going to go 1/8 of an inch on that. We're going to be ginger on this. And we're going to do 1 finishing pass down at the bottom, which again, we don't really need a finish pass on the bottom of the hole, but it acts as a spring pass to compensate for cutter deflection. Okay, our finishing step down, we're going to set that at 10 thou. We're going to finish at final depth. We're going to rough the final. We're going to use even step downs. And we don't need this islands parameter. It keeps popping up. I would turn on the smoothing because this is a small diameter hole and it's going a curved path. Our finishing step over, we want to set to 10 thousandths. And like with our profile on the outside, we're going to go back to the height tab and we're going to go -0.05. We're going to go 5,000. No, 0.005. We're going to go 5 thousandths deeper in the hole just to make sure we don't get flash when we deck off the opposite side. Now we go to our linking tab. We're going to remove our vertical lead-in radius. And let's leave everything else at default and see what we get here. Yeah. Alright, so we got our plunge straight down, rough cut, rough cut, rough cut. Now it looks like our we're cutting air here. So how you fix that? We're just going to go to edit. We're going to go back to our heights tab, and instead of the top height being the stock top, we're going to go to selection, and we're going to pick the top plane where our hole starts. and that'll eliminate some passes that are just going to cut air. All right, our next operation is we're going to roll the part. We're going to roll the part so that the threaded holes are facing up. Okay, so we're going to center drill these two holes. We're going to go drilling, drill. We're going to select our chamfer mill from the UMC library. It's the 3/8 chamfer. We're going to select that tool. We're going to keep the default settings. We're going to go to geometry. We're going to select our two hole features. We're going to go to the multi-axis tab. So we're going to go from tool to the multi-axis tab. We're going to pick our tool orientation. We're going to select our z-axis as normal to the plane I just selected here. That flips our z-axis. And our x-axis reference looks like it's already right, although I just selected it, making it wrong, and flipped it. So we want the x-axis pointing to the right-hand side. We're going to go to geometry, and we're going to select our hole faces, which are this one and this one. We're going to go to our next tab, and all we're doing is center drilling this, so the default is going too deep. We're going to go from heights, and we're going to leave everything at default till we get down here to the top height and bottom height. We're going to base the top and bottom height off the top of the hole, because we're going to manually tell it how deep we want to go. There isn't geometry here to drive it unless you put it there. And if we want a 10 thousandths chamfer on either side for this feature, we need to plug that in. So we're going to go to the whole top, but then we're going to go negative half the diameter of our countersink we want. Okay, so the major diameter of a 1032 thread is approximately 190 thousandths. So if we take 190 thousandths and we want a countersink that's 10 thousandths per side, we're going to add 20 thousandths to that. And then we divide it by 2, and that gives us 105. We're doing 2 because it's a 90-degree chamfer, so the depth is basically the radius of the countersink we want. So we're going to go a negative 105 thousandths. Okay, and that should give us a nice chamfer on that. Okay, we're going to do something different than I've done in the other videos. We're actually going to go ahead and continue with this tool and go ahead and do a rotation. It saves tool change time. And this way we can basically duplicate this with a different diameter for the hole here. So let's measure what size hole we're machining here. We are going to have a 156 thousandths diameter smooth hole there. So that's the number we need to change. We're going to go edit. We're going to go to multi-axis. We're going to select a different face for Z. Make sure you're looking at the icon. And we got our x-axis going horizontal. And we're going to select a different edge for that. This one. And then make sure your arrow is facing to the right. Okay, so now we're going to go to the geometry tab, and we're going to deselect the faces we had before, select the new one, and then on the depths, because our hole is a different size, we're going to go back and do our math here. If we have a 156 thousandths diameter hole, and when we add a 10 thousandths per side, or 10 thousandths per side countersink, so it's 20 thousandths bigger, plus 0.02, we're going to divide that in half. It gives us the radius. We're going to go negative 88 thousandths, and that'll give us the 10 thousandths net chamfer on this smaller hole here. And we can hit OK. Alright, so now we could either stay in this position and drill this hole, or we can go back to tapping the other two holes. Let's go ahead and put this hole in. We're going to have to make a tool for this. So we're going to go to drilling. We're going to select our hole. I'm sorry, we're going to select a tool. Now there's a couple ways you could approach this. You could take the tool you currently have selected and we could modify it, which is what we're going to do. But you could go off the base libraries that the vendors give you. So we're going to highlight this tool and we're going to start off by copying it. And then we're going to paste it. And then we're going to edit this tool. Okay, so we don't want two tool 11s. Okay, our cutter is not going to be this. It's going to be a 156 thousandths diameter tool. Okay, so a 156 thousandths drill bit is really 3/16 drill bit. So we're going to put in 3 divided by 16 inch drill. We're going to clear out the kind of metal information. This is just going to be a generic drill bit. We're going to go to the cutter, and this is where we need to put in the diameter is 0.156, and our shaft diameter is going to be 0.156. The tip angle is going to probably be 118 degrees because that's your standard drill tip. And we'll leave the overall length at 3, and we'll just round these off. We can leave the flute default. For what we're doing, we're not going significantly deep. And then we're going to go to shaft. We're going to keep that at default. We go to holder. We'll leave that at default. Cutting data. It's pretty close to the same diameter as what we were using, so we'll just leave those at default. A lot of times I'm tempted to round this off to an even number. And we'll leave all the feed rates at default because they should be relatively close for the same size, similar size drill bit, and the chip load should calculate correctly. We're going to go to post processor, and we're going to change this to tool 50. Okay, our magazine is big in that tool magazine in those machines. There's plenty of room, but we want to make sure it's out of the way of any other tool libraries we have. Is checked. That should be about everything we need. Hit accept. We should have the decimal equivalent showing up here. Looks like I misspelled inch, but IB, it should be IN. Okay, so there's our cutter. Make sure it's 50, not 11. We're going to select that tool. The default feeds and speeds go in. Our multi-axis, we need to select the tool orientation. Our z-axis face is there. Our x-axis is going to be this horizontal line here. Everything looks correct. We go to geometry. We're going to select the hole that we have. It's a cross hole. Now your models, you might need to do different settings. The drawing did not define how deep this went, so I went to an arbitrary depth, and so it wouldn't break through. So for the purposes of this device, it's going to hold onto a shaft that a set screw in this cross hole is going to hold onto. So as long as the shaft goes in, I don't think it really matters as long as you get some contact there. So I am going to select on my heights to just leave everything at default. But if you modeled your hole to go all the way through, you might need to change your end condition for it to stop. We don't want this to drill significantly deeper than what I have shown on the screen here. I believe I went about 400 thousandths deep. I am going to check this box to break through. That just makes the actual hole diameter the same as what was modeled. Okay, but again, we don't want to bust through here. It wasn't defined in the drawing. It should have had a depth call out. All right, we're going to go to the cycle. We're going to use the deep drilling cycle. It looks like it's defaulting to 40 thou pex. We'll do 60. And we'll let that go.